Okie dokie. So this is gonna be lesson 1D, and I'm gonna try to make it as short as possible and go to the point. So parallel to line through a point, parallel to line on the point, so parallel to this line. So this is gonna be a line, right? Now let's make it a line segment just for the sake of doing it, right? So right here, so let's call this point A. You don't have to choose this point, you could have chosen another point over here. All right, now through a point, where could the point be? Well, let's have the point right here just for the sake of doing it. So what we're going to do is we're going to make it an angle, so we're going to connect those points. By the way, what you want to call this point, let's call this point P, just for the sake of argument. Now we're going to use the method of copying an angle. How do you do that? Well, the same way as you did on lesson 1C. Swing an arc, right? So now you know the length. This is like the length of, well, it's the length of a radius. So this is your swing an arc. Now you're gonna go to point P and you're gonna do the same arc. See that? So you swung an arc and you went to point P and you swung another arc. Now you measure the opening, okay? We're talking about B and C. Let's call this point B, let's call this point C. Okay? So now measure the opening of BC. So this is the opening of BC right there. So the same opening, I'm gonna go to my new point that I have here. You wanna call this B prime, so it can be identified as being the copy of B. And just swing an arc. And we're gonna call this C prime. Why C prime? So if you know it's the same location as C, and then all of a sudden just to go like this. And voila, parallel lines, okay? Pongon, parallel lines. And the reason being is that this angle right here is congruent to this angle, because they are corresponding angles. This is a copy of this angle. It's in the same relative position. I hope you understand that. If not, don't worry, then wait for the lesson on parallel lines. Okay then, so here is the headache of everybody. So I'm supposed to bisect, okay, the perpendicular bisector of all of them. Well, as before, we had a problem doing this. So what we're going to do is in our notebooks, I'm going to draw different triangles as well as you are going to do, and we are going to find the perpendicular bisector. The triangles, please make sure that they're not right triangles and that they're not equilateral. If you make them equilateral, we're gonna have a problem, because then you're not gonna learn anything, because in the equilateral triangle everything is on the same line. Okay, so construct the perpendicular bisectors, and we're gonna call this BAC. All the triangles that we do, we're gonna call them BAC. Got it? Okay then, so how do I do the perpendicular bisector? I had said that you could use the process of constructing your equilateral triangle if it fits on the paper. But I just want to say something right now. It doesn't have to be from one segment to the other. It could be, the only requirement is that it has to be more than halfway. And I'm going to explain to you why. So let's say let's make a circle just for the sake of doing it. So I make a circle, right? So this circle is 10 inches, right? Then with the same length, I'm gonna move to C, okay? To C, and I'm gonna do another circle. Notice that the circles don't have the radius of BC or CB, but they do have the same radius. I said that the radius here was 10 inches. So anywhere I go on this circle is going to be 10 inches. We agree, because as the radius, 10 inches. Well, anywhere I go on this other circle is also going to be 10 inches from point C. See, this circle is 10 inches from point B. This one is 10 inches from point C. At this point, my friends, this point is 10 inches from point B because it's on this circle. But guess what? It's also 10 inches from point C because it's on this other circle. So it is equidistant from B and C, which is what I want. The same thing goes for this point over here. So that's why this is the perpendicular bisector. It doesn't go from the vertex of the circle. It's a perpendicular. It has to be 90 degrees and touch at the midpoint. Okay, so I did BC. So BC, check. Now I am going to do, what, AC or BA or AB? Let's do AC. So I like to move my paper here. So that's exactly what I'm gonna do. So in this case, look at this. This circle is already 10 inches from point C. That's why, and this point C, not point A. See that? That's why, and it goes more than halfway of the segment of AC. So I could actually use this. So all I would need is another circle from A that has the same radius, right? As this one, which I don't have to move the compass, I just have to do this. See that? Now, I got this point and I got this point right here. Well, all I gotta do now is just connect the points. See that? I connect the points. So I have this perpendicular bisector and this other perpendicular bisector. What was that perpendicular bisector of? AC. So all I need now, okay, so I did AC. So all I need now is the perpendicular bisector of AB. Not a problem. So I move the compass. I'm not gonna go, oh wait, look, I got this circle right here, B, that goes more than halfway the length of the segment AB. So I could actually use this segment. Now, let's see. And I got this same circle for A, look, same length, same radius. So I could use both of them. So that tells me that this, my friends, is the intersection of the other perpendicular bisector. So anyway, what is it that I need you to see? That these, and this perpendicular bisector intersect at this point. This is called the point of, and if you want to write it, you need to, concurrency. Concurrency. The points are concurrent, okay? Not only that, the intersection of the perpendicular bisectors, please in your notebooks write that. The intersection of the, and let's try to use vocabulary right here and symbols, of the perpendicular bisector is called, it's called the circumcenter. And I am going to show you why it's called the circumcenter as soon as we do two more triangles, okay? Because we really need to get this down pat. All right, so let's do another triangle. Okay, I'm gonna measure just so it's not so big. So 1, 2, 3, 4. Okay, I'm gonna measure 4 centimeters right here. Okay, and I'm gonna measure, I don't know, you know what? Just do it. So as long as it's okay. Okay, perfect, right? And I said we're gonna call it a I said we were going to call this B A C. Now you want to call it ABC, I don't have a problem. So let me start doing the perpendicular bisectors, but now please pay attention to this one because it's going to be very simplistic. I'm gonna open more than halfway. I did right? Look carefully at the parts that I need on the perpendicular bisector. I need this part, and I need this part right here. Of the circle that I drew, I just need these two parts. Now I'm gonna go with the same radius, and I'm gonna go to C, and I need this part right here, and I need this part right here. Now look at what happened. This doesn't intersect this one, and this doesn't intersect this one. Oh well, so that means that I only needed a little more of the circle. That's all it means. So look, it intersects now, and this one intersects now. See? So now I don't have the two circles intersecting like that. I don't have a whole mess. I only have a couple of, marks, which are the most important when you're doing constructions. So now, perpendicular bisector. What did I do? BC. So I marked that I did BC. Let's try AC. So look, I turn the paper around. And now I'm gonna do AC. So what is the criteria? All you gotta do is open more than halfway. Is this more than halfway? Yes. So all I gotta do is this. A semicircle. Why am I doing a semicircle? Just to differentiate between the one that I did before and the one I'm doing now. So here, and now you go to A. And look, I only need this mark right here and this mark right here. So I know where I am working, what I'm working on. And now, perpendicular bisector. Okay? So what did I do now? I just did AC. Finally, I'm gonna do AB. Okay? So what am I doing? I open more than halfway. Well, which basically this is more than halfway. Okay? I'm not gonna do it. If I do more than halfway, I'll be using the same radius I'll be using for every other circle. I'm gonna use less than that. So this is still more than halfway, right? So look, you need this part and you need this part right here. Now it's gonna get confused. So you know what? Let me try the one that looks like mostly the circle. That's the one I'm doing right now. And then I'm gonna do the same thing here. The one that looks mostly like the circle, that's the one I'm doing right now. Okay, so this one looks like a circle, so I know, and this one looks like a circle, so I know that my intersections are right here and right here. And you gotta watch out, you gotta be careful, okay? Now, I must have done something, let me see. I must have done something different because I don't see them intersecting at the same spot, all three of them. Oh well, it doesn't matter. No, it does matter. Oh my God, no, they do. Oh gosh. They do intersect. That's, oh, you see? This is, let me put arrows, okay? One, the second, and the third. Okay? That's what you have. So that is the construction of your perpendicular bisectors. Okay then. So you see that it can become messy. Now, funny thing is that here I try to draw just the marks and it looks more messy. Okay? All three intersect, right? It looks more messy than when I did this. So, I don't know. You choose, okay? It looks like three circles can actually do all three perpendicular bisectors. Nah. I don't know if my theory is correct, but if it's correct, let's try it once more with another triangle. Okay, you could see what I wrote there, so I'm gonna try a new page. Yeah, this one. So let's try a different triangle. Yeah, you thought I was gonna do equilateral. Hell no. I just wanna prove my theory. Okay, so what are we calling this one? B, A, C, correct? All right then. So I'm gonna prove my theory. I'm gonna try with the longest side. I'm assuming that BC is the longest side or AC is the longest side, whichever. So I'm gonna open more than halfway. You tell me if what I did was correct. So this is more than halfway, right? So I'm gonna do a circle. Okay? Now I'm gonna go with the same radius. I'm gonna go to C and I'm gonna do another circle. Correct? Notice that I already have the perpendicular bisector of BC. So I'm gonna go ahead and do it. Now I'm gonna do let's do BA. Okay? Notice that I already have a circle on B. And it also goes more than halfway the segment of, look, more than halfway this segment. Actually, it almost goes to the end of the segment. That means that I don't need to draw another segment. All I need is to keep the compass with at the same length, because it is bound to intersect this circle. So I'm just gonna draw another circle. Well, it won't be able to, but it's more than enough. So now look, circle A, circle B. So this must be the intersection of the perpendicular bisector. Correct? And now let's do AC. Funny thing with AC is that now, let me see what I have on AC. AC right here. I'm gonna put it this way. Okay, I already have a circle C and I already have a circle A. So that means that all I have to do is look for the intersection of these two circles, which is right here. To me, it really doesn't make any difference whether you do the circles or the arcs or want to change. As long as the arcs or the circles intersect to form the perpendicular bisector, you're good, okay? Now let me show you what's so peculiar. So this is the point of concurrency and it's called the circumcenter. Circum means around, okay? Center, this is the center. What does that mean? Watch carefully. But let me ask you a question first. Is it possible to draw a circle, like let's say, do you think I can draw a circle around this triangle? Okay, you said yes, it's fine. What about this triangle? Well, if you said yes, and I kind of agree. What about this triangle right here? What about that triangle? Can I draw a circle around this? Well, guess what? If your answer to that was yes, you might be right. The idea behind the circumcenter, in other words, the point of concurrency of all three perpendicular bisectors is that when you place your compass here, okay, let me see, I'm gonna zoom out, okay. When you place the compass here, and then you put the other piece of the compass in one of the vertices of the triangle, it will be equidistant. This point is equidistant to C. I don't know if you see it. It's also equidistant to A, you see? It is also equidistant to B. What does that mean? That I can finally, if you want to, you could draw a circle around the triangle. You could circumscribe the circle around the triangle. Hopefully you see it. You see that? This is what we call circumscribe a circle around a triangle. Okay? See that? That's it. So I hope you got enough practice. So now you know what to do when you have the three perpendicular bisectors together. They are powerful enough to show you that you could actually draw a circle around the triangle perfectly. Okay, so triangle, all right, no problem. So this is the center of the circle, by the way. You know this is the center of the circle. And each vertex of the circle is a radius of the circle, right? Remember, look, a radius. It's a radius of the circle. Okay, all right then. So hopefully that takes care of the confusion that we had with the perpendicular bisectors, because I had a triangle on my previous lesson that really didn't fit on the paper and we couldn't even do the perpendicular bisector. Okay then, let's move on now. Let's go back to the packet. So here, what does it say? It says two homes are built on a plot of land, right? They are built on a okay, so now what they want to do is they both have dogs and they are interested in putting up as much fencing as possible. So they want the fencing up in between this. That's nothing. Okay, you already know what to do. So this is the homes, right? So all you need to do is remember the point of the set of points equidistant from this and this is the perpendicular bisector. So now you know that you don't have to open it all the way to the other home and do the equilateral triangle. Now you know that you could just open it more than halfway the distance and do two circles or two arcs, right? That. And That's where the fencing will go, in between. You've been doing this for a long time. Okay then, what about if we add another home? How can we make the fencing equidistant from all three homes? Psh, think about it. 3 points. What kind of polygon did they form? A triangle, right? Look, you shouldn't be thinking about connecting the triangle. I'm just gonna show you, but really you shouldn't be connecting this triangle. Okay, that's a triangle. So all I need is to create the perpendicular bisector of each side of the triangle. So that's exactly what I'm gonna do. So let me just erase this. I don't want you to have the triangle, because it's not just, it's a triangular situation, but it's not always gonna be the triangle. So we're gonna construct the perpendicular bisector between these 2 points, right? So what do? We open the compass to more than halfway the length, and we swing, right? Then here, we do the same thing. We swing. Now you got your first perpendicular bisector. That's between H1 and H2. What about between home 1 and home 3? Okay, so open the compass to more than halfway. And you know what? I'm gonna use the same arc because look, it's already more than halfway. The only thing is that this doesn't have an arc, so with the same radius, I'm gonna draw another arc. Well, or at least the marks. Okay, second perpendicular bisector. Alright, so now we need the perpendicular bisector. We need all the points that are equidistant from home 2 to home 3. So once again, I'm gonna use the same measure that I used for home 2. See that? Because it's already more than halfway. Halfway all the way to home 3. So here, now with the same radius, mark over here, mark over here, and we got that. All right then. So this point is equidistant from home 2, home 3, right? So the fencing should go this way. Now, also, the fencing needs to go this way as well, because this way is actually equidistant from home 1 to home 3. And this right here is equidistant from home 3 to home 2. So in reality, I think that what we need the fencing to go, let me see if you can see it. Oh, you can see it. Okay, between home 1 and home 3, you got this area right here. Between home 2 and home 3, we got this one going right here. Between home 1 and home 2, you got this part right here. So my friends, problem solved. The fencing should go this way like that. So each of them has the same, I guess the same area you want to call it for the dogs, okay, and the same fencing. Let me see what else. No, that's it. Okay, then let's move on. So here, the circumcenter is shown right here. So let's see now. The question that arises here, okay, are why are the perpendicular bisectors concurrent? Well, we already explained that. They all intersect at the same point, and because they are equidistant from each vertex of the triangle. So recall that all points on the perpendicular bisector are equidistant from the endpoints of the segment, which means the following. P is equidistant from A and B, okay? Since it lies on, point P is what? Between A and B. Okay, it lies on the perpendicular bisector of AB. So on the perpendicular, okay, bisector of AB. Okay. Now, point P on B, right? Point P also, point P is also blah 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 from B. Point P from B. Point P is also equidistant. I know you knew that. Okay? from B and C since it lies in the perpendicular bisector of BC. Cool. Therefore, okay, point P must also be equidistant from A and C, of course. Then it goes on to tell you that hence, okay, AP is congruent to BP. Okay, I'm gonna read it and I'm gonna show you. So it says that AP, this line right here, where is that? Okay, AP, okay, it's also equal to the distance of BP, which is also equidistant to the length of PC or CP, whatever you want to call it. Okay? Yes? Okay, so now what it says. So this suggests that P is the point of, what do we call P? Besides the circumcenter, we call it the point of concurrency of all three perpendicular bisectors. You have also worked with angle bisectors. The construction of the three angle bisectors of a triangle also results in a point of concurrency, which is called the circumcenter. Alright? Cool then. Let's move on. Okay, this is a chicken of another farm. So, this problem says, use the triangle below to construct the angle bisectors of each angle in the triangle to locate the triangle's incenter. Oh gosh, they're talking about incenter and they haven't even told us what is it. Well, I'm going to tell you right now. As the perpendicular bisectors have a point of concurrency called the circumcenter, the angle bisectors have the same thing. Okay? So, let's do it. How do I do angle bisectors? Easy. So, you go to the vertex, you swing an arc, right? Then you measure the opening of the arc and you swing another two arcs, which in reality is like you draw another two circles. So from here, oh wow, we didn't label this. Let's call this B and let's call this C. Okay? So you open the compass to the length of BC and you swing an arc. Okay? Look, arc. Now you go to C and you swing the other arc. And now, this one, since it is not a perpendicular bisector construction, you go from the vertex of the circle and you go big, okay? You go long, like this. Nice. Okay, now what? Hello, you gotta do it to each and every other angle. Okay, so open the compass. I'm gonna do it to C then. So what is it again? Point on C, swing arc, okay? You want to call these points whatever. I'm going to call it M and N. M and N. So now, open the compass to the length of the opening. Boom, right? And now you're going to draw two circles. In other words, two arcs. Arc right here. And now you go to N. And arc. And arc right there. Or circle right there. I really don't care what you want to do. Okay. And now I connect from the vertex. Okay, from the vertex to the point of intersection. Okay then, so this one doesn't look so straight, doesn't matter, I just erase it, now everything is straight. So this is a ray. And then, guess what? You gotta do the same thing to B. But of course, I already know what's gonna happen because I gotta go from the vertex of B. So all I gotta do is draw it. Because I know, I already told you, they're concurrent. So if you want, I could construct it and I don't have a problem. So I draw arc, boom, okay. And then I open to the length of the arc. Okay, then I swing arc. Then I go to the other one and I swing arc. Then when I connect it, look, I don't even need to do anything. Look, the line passes through there. So now what do you need to know? You need to know that this is called the incenter. Okay? You need to know that that is the point of concurrency. But the most important thing is the difference between angle bisector and perpendicular bisector. Okay? In a perpendicular bisector, in the perpendicular bisector, where is it? In a perpendicular bisector, you were able to draw a circle around the triangle and the intersection of the perpendicular bisectors was the center of your circle. here, the intersection of the angle bisectors is the center of your circle, but not the circle around the triangle, but go put the metal tip in here and swing until you only touch one part of the triangle. Swing until you only touch one part of the triangle, okay? Because if you do, if you only touch one part of the triangle, this is what's gonna happen. Look at this. One part of the triangle. Now look at what's gonna happen right now. You see what's happening right now? Oh my God, this is awesome! I was able to draw a circle, a perfect circle inside a triangle. This is what you call inscribing a circle inside a triangle. Okay? The intersection of the angle bisectors is the center of the inscribed circle. So, okay. This point right here is equidistant, okay, to the point right here on the circle, the points that it intersects on the circle. And it has to, okay, because this will be a radius of the circle. This is a radius of the circle, and this is a radius of the circle. So it has to be. Not only that, this point, this circle, this radius right here would have to be perpendicular, okay? It's basically equidistant, okay, to a perpendicular drawn from this point to the sides of the circle, okay? All right then. So anyways, state precisely the steps in your construction above. Okay, I'm gonna tell you right now what you're gonna say. Construct the angle bisector of angle A. Construct the angle bisector of angle B. Construct the angle bisector of angle C. Label the point of find the in center. Okay. And let me see. No, that's it. That's what, basically. You all you have to do was up to here. It doesn't say anything about inscribing a circle. Okay. So anyway, so let's see what it says here. Anyways, earlier in this lesson we explained why the perpendicular bisectors of the sides of a triangle are always concurrent. Using similar reasoning, explain clearly why the angle bisectors are always concurrent at the in center of a triangle. Because again you're gonna say the following. Let me see. The angle bisectors are always concurrent. So this angle bisector is always equidistant from these legs right here, from the legs of the angle C. Sorry, I wasn't looking. This angle bisector is concurrent to these two legs. This angle bisector is concurrent to this leg, right? And this angle bisector is concurrent to this leg. At this point, they all meet the point of concurrency. Then at this point, this becomes the center of the inscribed circle of the triangle, okay? So that's it. And it's also equidistant from, okay, from the perpendicular to a side on the circle. Oh my God, I just got confused. To the perpendicular on the side of the triangle. All right then, let's move on. I don't want this to take that long. All right, so these are examples right here. See that? Perpendicular bisectors don't need to intersect on the inside of the triangle. They could be on the outside in an obtuse triangle. Now the in center will always have to be inside the triangle because hello, it's a center of a circle that is inside a triangle. So the center cannot be outside if the circle is inside the triangle, right? Now here I really don't care because the triangle is, the circle is outside the triangle. All right. So let me see now. How can you, what the hell is this? How can you use what you have learned to find the center of a circle if the in-center is not shown? Wait, if the if the center is not shown. So if I was to find, how can I find the center of the circle if the center is not given? I don't know. I really don't know. Oh well, don't worry, you'll figure it out. You're awesome. So let's see now. Find the center of a circle below. Oh gosh, I don't know what the center is. So what the hell am I gonna do? Wait, this one has something to do with finding the center. What if I didn't have the center? Contrale. I don't know. Maybe if I do this. And I do this, I guess, and just do the perpendicular bisectors. Let me see. Open more than halfway, right? And just do this. Halfway. Let's do this. Connect. And now do this one. I'm gonna do this one right here. Oh, sorry, you cannot see. Okay, which one am I doing? I'm doing this right here. I don't even know what, I didn't even call it a side. And now I'm gonna do it this way. So it's this point of intersection and this point of intersection. Now notice something. If I do the perpendicular bisector of this right here, it will also go through this point. Am I correct? If not, then let's just finish doing it. Look at what I have here. It's already more than halfway the segment. What the hell? Right here. You know how to construct perpendicular bisectors now, right? That will be the third perpendicular bisector. Oh, what? Nandate. Soka. Oh, this is the center of the circle. Duh. When you have the perpendicular bisectors, the point of concurrency is the center of your circle. Oh my God. Why didn't I think of it before? Actually, no, I did think about it. I already knew it. So now you should be able to do this and use your knowledge to do the following. You don't need, and I'm telling you right now, but if you have to do it, you do it. You don't need all three perpendicular bisectors. Look, this is the last bisector I did. Even without this bisector, I had already found the center of my circle. Because the third bisector is bound to do this. Okay? Now in ancient Greece, of course, they had to draw the triangle because that's what they figured. Now, how about the next problem that I'm giving you right here? Okay, it says the arc shown is part of a circle. Find the circle center and then complete the circle. Okay, so find the center. Now, I'm gonna pause this right now. Well, at least for my students. And you're gonna try to do it. Now that it's on pause, look, as I said before, if you only need two perpendicular bisectors here, then that means that how many sides do I actually need? 2. I only did 2 sides of the triangle. If I had the opportunity, I would only do 2. I did all 3 to show you, but I don't need this, so that means I only need 2 sides. Well, in right here, and I'm gonna give you this explanation right here. Well, quick review. Let's do a circle. Okay. Circle, that's a circle. Quick review. What's the ruler? Okay, right here. Anything going from the center, any segment going through the center is called a diameter. Any point going through the center is called a diameter. These are 2 diameters, okay? So radius, 2 diameters. Now, anything going like this, you know, not through the center, is called a chord. Look, chord. You need to write this down. Chord. Look, this is also, diameter is a special chord. It's the longest chord ever because it goes through the center. If it doesn't, it's shorter. Look, chord right here. Chord, okay? Chord. Nice? Okay, understood. Chord. So, what I'm going to do now, since I introduced your new vocabulary, is I am going to draw 2 chords. One from here to here. Another one from here to here. Oh look, I could actually connect this and make it a triangle. Oh my god, I'm so sorry. Okay, so I drew chord right here to right here, and then chord from right here to here, and I could actually connect these points and make it a triangle. Should I do that? No, I'm not gonna do it, even if you ask me to, or maybe I do it. Okay, so I'm gonna do the perpendicular bisector right here. So perpendicular bisector right here, I go like this. I draw my line. See that? And now I'm gonna do the perpendicular bisector of this line right here. So I open more than halfway, okay, and I do like this. Okay, now I go to the other point of intersection right here, to the other end point of the segment, and I do the same thing, and I got my perpendicular bisector. It would be unfair and not good if you just do a perpendicular bisector like that. That's nothing. That's not showing me the center. So what you need to do is you need to actually grab your ruler and, like a man, do this. See that? And guess what? Now I found the center of this circle that was given to me. Of this circle. Okay, so it says, find the circle center, then complete the circle. Sure. Now that this is the center, now I can complete the circle. I don't have to be, gambling and say, oh, that's what it is. So look. Oh, beautiful. Let me see. Okay, not good. Open, 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 open. Okay, that's the circle. Let me see. Kind of. Okay. So, let's do this. Let's see. Where does it go? Okay, this should be enough. So I'm gonna complete the circle. Yeah, how you like me now? The circle is complete because I found the center. So this is how you find the center of a circle. Yo, stop dancing. So that's it. Okay, so what else? Okay, circumscribe a circle around the triangle. Sure. Circumscribe means what? Perpendicular bisectors or angle bisectors? Right. Perpendicular bisectors. So I'm gonna try to see if I can do the 3 circles right away, if they fit in here. Is this more than halfway? Yes. Will it be more than halfway here? Yes. Will it be more than halfway here? Yes. So that means that it works for everyone. So I'm gonna draw the 3 perfect circles. Okay, let me see. Oh yeah, sure, you could see it. So 3 perfect circles. 1. Okay, now with the same length, I'm gonna go to C. And I'm gonna do the same thing, okay? I don't have to do the circles. You could only just do the arcs and it's fine, okay? And now I'm gonna do BC. Well, I didn't have B, but now I do. And for C, I already have this. You see that? I already have it. Okay then, so manos a la obra. Let's see what's up. So the first intersection, okay, was this one right here. Between B, no, this is circle C and circle B. Okay, so we got the first, boom. Okay, now the second one was, okay, AC would be, this is circle A, this is circle C, so this is the intersection. Then, this is circle A and this is circle B. So this point right here, wait, no, I didn't do it. Okay, now we're talking. So this point right here and this point right here is the intersection of both circles. There you go. Look, we got the circumcenter. And remember, the perpendicular bisector, the circumcenter is equidistant from the vertex of the triangle. So we got this, right? Look, equidistant, equidistant. So I just go and draw my circle around the triangle. That's it. That's all you gotta do. Okay? Steps. Draw circle A with radius AC. Draw circle C with radius CA. I mean, you didn't really do that, but that's the idea. Unless you wanna do construct perpendicular bisector of AC, construct perpendicular bisector of CB, construct perpendicular bisector of BA. Okay? Then find the circumcenter, place compass on circumcenter and on vertex, and then go around, and that is your circumscribed circle. Oh, okay, now I'm supposed to inscribe a circle right here. All right, there is some methodology to do this. There's a process, but I'm just gonna show you the quick one. Okay, so inscribe, in means angle, circum means perpendicular bisector. So inscribe means angle bisector. So look at what I'm gonna do. So I'm gonna do my circle right here. Okay, that's an arc. Then I'm gonna do an arc over here as well. Then I'm gonna do an arc over here. I'm just doing the same thing over and over because I don't wanna do an angle bisector for each of them. Okay, now here we go. Oh, measure the opening. Okay, measure the opening and do two intersections. Oof, very close intersection. Let's see now. Oof, very close intersection. What was it again? Okay, so I did this right here, so that, and then I did this. Okay, so this is the intersection point. And that one I'm actually gonna do right away because I don't want to lose it. So the angle bisector goes from the vertex of the angle. Okay, I got the arc over here, so I'm just gonna go here, open to the length of the angle, okay, and just draw two circles or two arcs from the points where the arc intersects the legs of the angle. These 2 points, this point and this point. Okay, so now I connect. This is for A. Okay, I'm not gonna do C because C it's automatically given. You know that it has to go from the vertex, so I just gotta go like this. See that? I could do it, and you know that it's gonna be the same thing. I already showed it to you. Okay then, so now let's do the little circle. How can I put it? No, I will teach you this later on in a different process. Right now we're just gonna calculate how to inscribe the circle. So make sure that you put the circle at the in center and you close it, right? Make sure that it only intersects the triangle once. At that point, you've done it. Okay, At that point, you've done it. So look. And voila, you just inscribe a circle. So, steps and explanations. Sure. Angle bisector of B, angle bisector of A, angle bisector of C. Okay. After finding the incenter, place compass on the incenter and inscribe the circle. There is one extra step though. Believe it or not, in order to do this perfectly, you need to find the perpendicular to this line, to this point of intersection. Once you find the perpendicular, in other words, create your own segment and then perpendicular bisector, you will be able to know where your compass should actually be. In the meantime, you could just inscribe it like that and it's still fine. Okay, you're not gonna get penalized. Okay. Inscribe a circle inside a given triangle. You already know how to do this. So start doing it. And now let's inscribe a circle. Just remember to try to put the compass as perpendicular as you can to the side that you're going to work with. See, this is a gamble because you don't know if it's going to be perfect if you're on the right side. But so far, it has come out good. Okay, let's move. Steps and explanations, you already know what they are. If you need more, then go back in the video or just ask me in class. Remember, angle bisector of this, angle bisector of that, angle bisector of that. Find the incenter and then trace trace that. Okay. Oh my god. Find the medians of the given triangle. Median. What's a median? Hello. It's a segment that goes from the vertex to the midpoint. So I got the vertex, I just don't got the midpoint. How do I find the midpoint? Easy. Perpendicular bisector, baby. Look, open more than halfway. Okay. You want to do the three circle version? Sure, we could do the three circle version. So this is already more than halfway, right? Yeah, more than halfway, So three circles, right? Since they're all gonna go more than halfway. So we're gonna do this one, circle A. You don't have to finish it. Then we're gonna do circle C. Okay. And now we're gonna do circle B with the same size. Secret that I just learned from you guys. Okay. Now, guess what? I'm not interested in the perpendicular bisector. I'm interested in the midpoint. I'm interested in this part right here. How do you like me now? I'm not interested in the perpendicular bisector of the segment. So I don't need to draw this line. I just need this midpoint right here. And same thing goes here. No. Which one is the perpendicular bisector of this one? Okay. Oh, I got it. It's right here. That's it. That's all I'm interested in. And now, from the vertex, you connect to the point. See that? From the vertex, you connect to the point. From the vertex, you connect to the point. Cannot see? Okay, I'm gonna do it from here. Like that, right? Don't tell me. The medians are also concurrent. Yeah. Okay, so what do you call the point of concurrency? Huh? Well, it's not the circumcenter. It's not the, what do you call it? It's not the circumcenter. It's not the incenter. Could it be that we have the centroid? Wait, yeah, I think it's called the centroid. How do I know? Well, because I would not leave anybody hanging. Look, these are the incenters. And for the medians, if you go ahead, because you're great students, look, for the medians, it's called the centroid. Okay? The centroid. So we're gonna call it the centroid. That's not a problem. I just wish to find where I am. And I think I found myself here. So this point is called the centroid. Okay? The point of concurrency is called the the centroid. Okay? So what? I mean, like, why do I need this for? Like, come on. Let's say these are roads or streets or whatever. So this is what I want you to do right now. Let's call the centroid point P. And I need you to measure BP. And okay, let's give a letter to each of these mid segments. So let's call this B prime, let's call this C prime, and let's call this A prime, just for the sake of doing it. So measure the distance from B to P, and then from P to B prime. From A, another group is gonna measure the distance from A to P, and then P to A prime. And then another group is gonna measure CP, and then P to C prime, PC. Okay? And then we'll discuss that, okay? Not a problem. So take a couple of minutes, like 2 minutes. Pause this. Pause that. Okay. So let us start discussion. What did you notice? Okay, from P to B, I have 3.5. From B to P, I have 1 and something. Okay, is there a better measure? Let's see. From A to P, I got almost 5. From P to A prime, I got 2.5. Wait, 2.5. Okay. What else? From C to P, okay. From C to P, I got 3.5, maybe. And from C to P prime, I got 3.5, and then here I got 1 and 1.8, something like that. So let's write down our measures and let's start estimating. Let's pause this. Cool, now it's on pause. And now you understand. The distance from the vertex to the centroid is twice as much as the distance from the centroid to the segment. The distance from the vertex to the centroid is twice as much as from the centroid to the segment. In other words, from the segment to the centroid is half as from the centroid to the segment. That's all you need to know, because you're gonna get a couple of problems that had to do with that. All right, here, find the altitudes. Finally, altitudes, you're gonna have to go back to when I asked you to draw a perpendicular to a line. Okay, this time you got your line segment right here. So let's see if you remember what you gotta do. The altitude is nothing more than a perpendicular line from a vertex on the triangle. In other words, a perpendicular line from this point B. So what do I need? I'm giving you a segment, but it's not good enough. So you're gonna have to create your own segment. You always create your own segment. Oh, look. Not bad, right? Not too shabby. I was able to catch the line right at the point here. So this is my new segment. Now that you got my new segment, it's like constructing the equilateral triangle or the perpendicular bisector, right? Perpendicular bisector. So let's do this, right? And then let's do this. That's your perpendicular bisector, your equilateral triangle. I don't know what you want to call it. The idea is that when you connect this point of intersection, right, it will go from the vertex and it will be perpendicular. Okay. Now guess what? It's not just one altitude. You gotta find all the altitudes. Okay. So I turn the paper around like this. I'm gonna go from A. I'm gonna find the altitude A. Cool. So what do I need? I need my segment. It's crazy, okay? You have to learn this. Construct the altitude. I'm gonna create my own segment that intersects the opposite twice. Jesus Christ, not even. Okay, you know what? It's okay, it's okay, it's okay, it's okay. Doesn't go over, no. Okay, I'm sorry, I'm gonna make it so long, but I don't care. Okay. Okay. So, I got... Are you kidding me? It actually intersected this thing? Let me see. It came... No, I have to extend this CB. I don't believe it. I don't buy it. You see? Thank God I didn't buy it. So this is the point right here. And of course, yes, I did get it at this point right here. So now that I got my new segment, I'm gonna construct my perpendicular bisector to that segment. If that's all there is. Or construct the equilateral triangle. I really don't care what you wanna call it. Something is not, oh, it's right here. That's your other altitude. And I'm telling you, it gets messy, but you have to keep track of what you're doing. So I did altitude from B, I did altitude from A, and now I gotta do altitude from C. So I'm just gonna make sure that I put the triangle in a comfortable position. So I need to create my own segment. Now that's why it's good to be noting on the side, okay, I just did this to that. I did A to BC. Now I'm gonna do B to AC, and now I'm gonna do C to AB. So go to B. See now. No, it won't. I need more, so I'm gonna have to extend this. I don't have a problem with that. You know what? I'm gonna take advantage of one of the circles that was already drawn. You see that? Yeah, I'm gonna take advantage of this circle that was already drawn. And all I'm gonna do is just extend AB. See that? That's all. I extended AB and now I got my new segment. And now, as I said before, to construct the perpendicular bisector or equilateral triangle, what you want to call, whichever method you want to use. So I'm doing this. So in this case, I'm gonna go full circle just in case I can distinguish. Okay, can I distinguish now? Yes, I can. So it's full circle with full circle. It goes right here. It goes right here. And of course, as soon as you let go, let's see, let's calibrate a little more. Does it go? Yes, yes, okay. So that's it. That's your altitude. All three altitudes, oh my God. Don't tell me all the altitudes are also concurrent. Yes, Becker, they're concurrent. Yeah, right. That's a new one, right? Now, what you want to call it? What do you call the center of the altitudes? I don't know. You call it the orthocenter. Orthocenter. Okay. So now, guess what? Let us review a couple of things. A triangle can have so many centers. It could have a circumcenter, which is a circle around it, right? It could have an incenter, which is the angle bisectors. It can have a centroid, which is the medians, okay? Twice as much as the other. And it also can have an orthocenter, which is basically the altitudes, okay? All right, let's see what else is there. Construct the altitudes of the given triangle. Okay, so I'm only gonna construct two altitudes, right? Oh, phone is calling. Okay, no problem. Hello? ¿Qué ondas? Estoy grabando. Hi guys, it's just a phone call. Okay. Bye. Ahí te mandé el mensaje. Bye. Okay, so now let's do the altitudes. And thank God I tried to make this shorter. So I need a segment. Okay, so I need to intersect. So I create a circle or a segment. I really don't care how you want to do it. So you draw a circle. Let me see. Will this suffice? Sure, why not? See that? No, you don't see it. Yes, you do see it. Okay, you see it? Barely, right? Let me zoom in. Now you see it, right? Yes. So this is gonna be my new segment. And now that I got my segment, you could call it AB if you want to. Okay. And now that I have my new segment, I'm gonna create my perpendicular bisector. You already know about the perpendicular bisector. If you wanna do it like the regular equilateral triangle, fine. Okay, like this. Like the circle A with radius AB, then circle B with radius BA, which I'm not doing, I'm just creating the marks. Okay, so now look, this intersection will definitely go through point, let me see, wait, okay. This is an intersection will definitely go through point A. Okay, now I'm gonna do, what did I do? I did angle A to BC. I did angle A to BC. Angle A to BC. So I know which one I did. Now which one should I do? B to AC or C to AB? I think it's gonna be best if I do, let me do B to AC. Yeah, let me do B to AC. Let me see if I actually can draw my own segment. So it's gonna be B, okay, to AC. Oh my God, it's not gonna work. You know what? Who cares? As long as it's there. Okay, so this is gonna be my new segment. Perfect. So now all I gotta do is create the perpendicular bisector of that segment. Because we already reviewed altitudes. Okay, so as I said before, you can construct your equilateral triangle method or just open more than halfway. Remember, that's what the perpendicular bisector does. You saw it too, right? It's right here and right here. So now I connect them. See that? From B. And I am not going to do the one from C because I know that this one is going to intersect this one at the same point. Make sense? Right. Okay, so I constructed all altitudes. Steps and explanations. Come on. Okay. Steps and explanations. Though I want to tell you right now what you would do. For the altitudes, draw circle A. Okay. Yes. Draw circle A. Create segment AB. And then construct the perpendicular to BC. And that's this one. Okay. Then once again, draw circle B so it intersects AC. Okay. And then create your own segment and create the perpendicular to AC. Now, is there an easier way to do it? Yes. Easy. Construct the perpendicular from B to AC. Construct the perpendicular from C to AB. Construct the perpendicular to from A to BC. And that's it. Okay. What else do we have here? Quiz 1D. All right. Locate the triangles in center. In center has to do with the angle bisectors. So all you have to do is create all three angle bisectors and your in center will be there. And to prove it, you could just draw the circle inside. Okay? Thank you.